Hi folks, welcome to Math with Captain Rod. I make this video here to help you understand, or I'll say answer the question that I know is on everybody's mind here. What is a derivative and how is it calculated? So, sorry about that. So we're going to talk about what I call the happy function, y equals x squared. I use this function a lot for just demonstrating concepts. I like to keep the functions simple when I introduce new concepts so that we don't get bogged down in the complexity of the problem. Furthermore, I've only graphed the first half of this. We're just going to look at this thing in quadrant 1. Now the first thing here before we move on here is I'd like to talk a little bit about slope. I'm going to draw a graph right below this. And there's a few things I'd like to point out. This graph is going to be, I'm going to put S here for slope against X. And when I talk about slope, I'm talking about tangent line slope. And you know, I'm going to go back and put the other half of that graph in. If I look at the tangent line right here, the slope of that tangent line is 0. So if I put this on my new graph here, my slope graph, that would be here. When x is 0, the slope is 0. If we move over to here, like x equals 1, you'll notice just by I'll say by observation here, the slope is some positive number. What is that number? Well, we'll get to that. But for now, let's just say, some positive number, which we don't know. Notice if I move over a little more, again, notice that the tangent line has increased in slope. And that means that this number here has gotten larger, right? If we go over here now, like if I look at this point in the graph where x is minus 1, you'll notice the slope is some negative number. Okay, so x equals minus 1, we're down here. Now, I'm just going to it does end up being linear. We'll see why here in a minute. But again, the very important thing is that if I look at this graph and I pick any point on it, the tangent line has here the slope of some negative number. Here a negative number a little closer to 0. Here's 0. Here's some positive number. Here's some bigger number. And as we move from left to right on this graph, the slope is increasing. So there is presumably some sort of function for that slope. I like to say s of x, slope as a function of x. So this function right here, that's what a derivative is. Okay, it's a function that tells you the slope of, I'll say, your starting function here. Now we're going to talk a little bit about how it's found. So what we're going to do is we're going to pick a point on this graph here, an arbitrary point here. So rather than putting a number on it, we're just going to call this x. This point could be anywhere on the graph. The y value that goes with that is f of x, which in this case is equal to x squared. Now, the tangent line, if I were to draw the tangent line here, looks like this. I'm going to draw this, give this kind of a cool color here. Let's use this. So here's our tangent line. Boom. Tangent line. All right. And again, the tangent line touches once. Well, when we do a slope calculation, you typically need 2 points to calculate slope. Think about algebra class. Slope is y2 minus y1 over x2 minus x1. We don't really have 2 points right now. We have 1 point. But what we're going to do is play a little math trick here. We're going to make up our second point. So we're going to imagine moving over a distance h. That makes our new coordinate now x plus h. No matter what x is, no matter what h is. Where we're going to just kind of assume that h is some small positive number. Actual number doesn't matter, but imagine it being like 0.1 or something, or 0.2. Our new point on the graph now is up here. And our new y value is f of x plus h. This is true for any function. And this line here, I believe the textbooks like to call this a secant line. This red one here is the slope of the line between 2 points. And so what we're going to do is we're going to start with this one, applying this. So our y2 minus y1 is going to be f of x plus h minus f of x. This is true for any function, any values of x, and any small value of h. Or I guess I could really say any h. Then we're going to divide that by x2 minus x1. And you'll notice if I take x plus h minus x, we just get h. Okay. Now, in this example here, what this would be is x plus h squared minus x squared over h, right? So what we have here is that our slope that we're looking for, I'm just going to call it m, is approximately equal to this, and we're going to mess around with it here in a little bit. I'm going to go back to this kind of more general form here, though. If we now, think about h getting smaller and smaller, all right? And this is a really important fundamental concept of calculus. If h got a little smaller, that means this point would move like over to here, and then this point on the graph would move down to here. And what you have to realize, here's the super important thing, is that the red slope got a little closer to the, what do I call that, kind of pinkish or purple slope, right? And if h gets even smaller, the red and the purple get even closer together, and smaller and smaller. Now, we have a process for doing this now called the limit process here. So if we take this expression and we put limit as h goes to 0 of f of x plus h minus f of x over h, we get this function here that I call the slope function. I call it s of x a lot. That's called a derivative. That's what the derivative is. There's different notations for it. A lot of times you'll see written dy dx. The d's in dy dx stand for differentials. It means infinitely small change in y over infinitely small change in x. Sometimes you'll see this written f prime of x, right? That also is notation for a derivative. So I'm going to go through and finish this example up here in just a minute, but by time we take this, it's called the difference quotient, and force h to 0, we're getting a function that tells us the slope of f of x at any given time. So finishing my example here, if we take the limit now as h goes to 0 of x plus h squared minus x squared over h, which is equal to limit as h goes to 0. People ask me, do I have to keep writing this? The answer is yes. If you want your lines to be mathematically correct, you have to keep writing this every new line. Okay, expanding this, that expands to x squared plus 2xh plus h squared. And then I'm going to put that in parentheses. That's this minus x squared over h, kind of running out of room. Give me just a moment here. I'm going to take this entire thing, shrink this just a tad, lift this up to give me a little bit more room. Okay, which is equal to limit as h goes to 0. Yes, you have to write it over and over and over. You'll notice these add to 0. We're left with this 2xh plus h squared over h. Again, limit as h goes to 0. Yes, you have to write it out over and over and over. You'll notice an h can be factored out of this, 2x plus h. And now we can take our limit easily. By the way, we can't quite yet, because if you look at this, if you take the limit of that expression as h goes to 0, you get 0 over 0, which is indeterminate. But after that h divides out and we take limit as h goes to 0, we get 2x. So there's what we were looking for. This function is what I call this thing right here. I like to call it a slope function. It's kind of my own language for it. S of x, the function that tells us the slope of this one, right, is what's called a derivative. It is the derivative of this function. dy dx is its notation. It's equal to 2x. You'll notice that this is a linear function with a 0 intercept. And look at the graph that I had plotted. And getting back to this discussion, you'll notice that as x equals 0, you get 0 out of this. Notice the tangent line has 0 slope. If I put, say, x equals -1 into this, you'll notice you get -2. Look at the graph. That's something like this. You'll notice a negative number. If I put in x equals +1, you'll get +2 out of this on my graph. If I go to the right and up 1, now this is not an exact graph. I'm just kind of ad hocing this basically, but you'll notice that x equals 1, we get a positive number, and so forth. So anyway, kind of a recap. What is a derivative, right? For any given function like this, you can calculate another function which gives the slope of the first one. And that's what a derivative is. And it is calculated by taking the average rate of change between 2 points, with the first point being x, second point being x plus h, and taking the limit as h goes to 0. I would call this right here the formal definition of a derivative. And again, here's an example of it using a simple function. But anyway, that's my short video on what is a derivative and how is it calculated. I hope that this helps. Have a great day.